All right, let's continue, please. CE. CE is going the same but the opposite. So the bottom right to the top left. So I'm going to call this one negative V, negative U plus W. Is that right? Negative U, W minus U minus V. Okay. Then we're doing finally BH, which is the bottom here to the top there. So I'm going to call that negative U plus V plus W. Somebody just confirm those for me. I think that looks good. Okay. All right, there's 9. Oh goodness, 11. I'm going to kind of leave 11 for right now. We'll go to 16. What's that? 11 you didn't get? That's when you want it. I'm going to talk more about 11 in the upcoming days, okay, so I'm going to leave that. And then move on to 16 as well, because I like 16. 16 was my favorite one from last night. Okay, it says ABCD is a parallelogram. Okay, guys, so stay with me here, please, okay? The way you draw ABCD, and this is very important, is you start at one corner. It doesn't matter what corner you start at. I'm starting at the top left, and you work your way around the parallelogram like that, okay? ABCD. Then a parallelogram means what? All sides are the same length and parallel, okay? So that means AB is equal to DC, and AD is equal to BC as far as vectors go. Then we're going to say that P, Q, R, and S are the midpoints of AB, so this is P, this is Q, this is R, and this is S. It says those are all the midpoints. Actually, I guess I could do it. Okay, why can I put one slash on the left and the right for that? Like, why are those going to be the same? Why is PB going to be equal to RC, for instance? Go ahead.
Because AB and DC are both the same length and it's the midpoint.
It's the midpoint, right? So we know then by fact here that this little tiny vector is going to match this, this, and this. You see that? And BQ then is going to equal this, this, and this. Okay, on the logic here? So it says what we need to prove. We need to prove that PQRS is a parallelogram. In order to prove PQRS is equal to a parallelogram, we need to prove two things. We need to prove that PQ is equal to SR, and we need to prove that PS is equal to QR. Are we okay on the logic there of what we're trying to do? Because that's what we want to do here. So what I'm going to do is I'm going to do this like an identity proof. I'm not going to touch PQ. What I want to do is I'm going to try and write the vectors of SR and combine them into ways that will add up to the same as this. So what's another way I can write SR? Okay, not all at once. What's SR? Go ahead, Dylan.
Isn't that SD plus DR?
SD plus DR, very good. Okay. Now here's the thing, I want that to equal PQ, so what I'm going to try and do is I'm going to try and make that equivalent to vectors over here, okay? So what is SD? What's another way I can write SD? What's SD equivalent to? BQ, okay? So what we said is that this vector is equal to this vector, this is equal to BQ. Okay, someone other than Bailey, because I know you got this. What's DR equal to then that would be useful to us? Yeah, PV. So everyone see what we're doing there, right? And we're doing a lot more of this tomorrow in tomorrow's lesson, assuming I get to teach today. All right, but in tomorrow's lesson, we're going to do a lot more of this proving stuff. So then BQ plus PB, I can't really do that, but I'm going to write that as then equals PB plus BQ. And then if I add this plus this, what does this plus this equal? PQ, and we're done. PQ equals PQ. and life cycles right side, right? So you see, just I want to make sure that we see what we do here, okay? Everyone sort of get the idea of what happened there? Okay, this is a little trick, I didn't get into this too much, I'm sorry. This is, I put this for homework because it was leading into a future lesson. Okay, that's why I put it in there, so I'm sorry. Hopefully I'm not seeing too many death looks. Okay, but that, one death look, okay, from the front. Okay, right, but that's it here, that. And I'm gonna quickly do the same thing for the other side, if that's okay. Okay, so PS equals QR. I'm gonna write QR as, do a little line down the middle. QR is equal to QC plus CR. QC is equal to AS. CR is equal to PA, which is equal to PA plus AS. So PS is equal to PS.
So just say K back and forth.
Therefore, parallelogram.
Sounds pretty complicated.
It is.
Just wait.
Good at that.
Now again, that looks easy, and it's nice and easy because Haley asked me for a class, and I thought I had a nice, beautiful solution for it. Okay, this is easy once you know how to do it, but before that, it's very difficult. Okay, and we'll go through a full lesson on stuff like this on Thursday. Okay? And don't stress out about whatever the one I didn't do. Don't stress out about 11 right now, okay, Alistair? Basically, what I would just do is I'd do vectors, like moving around, right? So truth and negative, like positive, move around. Let's go on. Oh my goodness. It's going to be the fastest lesson in the world. Here we go. Brad, come here for a second, please. Another time before I leave. All right. All right, here we go. Multiplying a vector by a scalar. Okay, so we're going to say for vector v, vector v, and real number c, the scalar multiple of u by c, or v by c, is a vector with the following characteristics. So I'll go out of the way. Characteristics. Okay, so what I'm saying is for this, you can multiply a vector by a scalar, and the result's going to be a vector. The magnitude of this is going to be absolute value of c times the magnitude of u. This is absolute value. Can somebody tell me what absolute value means? If I say, like, what's the absolute value of -10?
10.
Just positive 10 is the absolute value. Okay. So what I'm saying is if I multiply something by 5, it's going to be 5 times the length, which makes sense. If I multiply something by -5, does someone want to take a guess what that means, please? So I multiply something by -5 in this case. So that? Yeah, you're multiplying the magnitude is going to be 5, but the direction is going to be in the opposite way, because the negative would be moving in the opposite direction. So my direction we're going to say if c is greater than 0, same as u. If c is less than 0, opposite of u. Okay, so if you multiply something by -5, again, if I say Mr. Sadler can lift 10,000 newtons worth of force, and I say Callan can lift 5 Mr. Sadler's, that means he can lift 50,000. If I say that Caleb can lift -2 Mr. Sadler's, he would be -20,000. All right, so you see the idea. 20,000 in the opposite direction, that's what I'm saying, okay? I'm gonna do a few more different definitions here, if that's okay. And then we'll do a few examples. Okay? Actually, I'm gonna take a break, actually, I know it's probably not a good time, but I'm gonna take a break anyway. Hit pause, and then we'll finish off the lesson.